Welcome to Blueprint to Reality. Today, we're diving into a core concept of structural engineering, rigidity. What is it and why is it so important in building design? Let's break it down step by step. What is structural rigidity? So, what exactly is rigidity? Imagine a ruler resting between two desks. If you press down on the middle, the ruler bends. Now replace that ruler with a steel bar. It barely moves. This ability to resist bending or deformation under load is what we call rigidity. In engineering terms, rigidity refers to how well a structure maintains its shape and resists deformation when forces like weight, wind, or earthquakes act on it. Essentially, the more rigid a structure, the better it can resist bending, twisting, or sagging. Types of rigidity. There are two primary types of rigidity. 1. Flexural rigidity. This refers to a structure's ability to resist bending. For example, beams in a building must have high flexural rigidity to support heavy loads without sagging. 2. Torsional rigidity. This is the resistance to twisting forces. Think about a bridge deck that can twist under high winds. If it lacks torsional rigidity, it may lead to instability or collapse. Each type of rigidity plays a critical role depending on the structure's design and the forces it will encounter. Why rigidity matters. But why is rigidity so critical in structural engineering? Let's explore a few examples. Skyscrapers. These tall structures must remain stable against lateral forces like wind or earthquakes. Without adequate rigidity, excessive swaying can make the building unsafe and uncomfortable for its occupants. Bridges. A rigid bridge ensures the deck doesn't sag or twist under the load of vehicles. Remember the Tacoma Narrows Bridge collapse? That was due to insufficient torsional rigidity. Everyday structures. Even smaller structures like homes or office buildings need to be rigid enough to handle everyday forces, such as furniture weight and weather loads, without deforming over time. At the same time, over-rigid designs can backfire by making the structure brittle, unable to absorb sudden impacts or vibrations. This is why engineers aim for a balance between rigidity and flexibility. Factors affecting rigidity. What determines how rigid a structure is? Here are the key factors. 1. Material choice. Materials like steel and reinforced concrete have high rigidity compared to wood or plastic, making them ideal for load-bearing applications. 2. Geometry. Triangular shapes are inherently more rigid than rectangular ones. That's why trusses, which use triangles, are popular in bridges and roofs. 3. Connections. Welded joints tend to provide more rigidity than bolted or glued ones. Proper connection methods ensure that forces are effectively distributed across the structure. 4. Cross-sectional area. Larger cross-sections, like wide beams or thick columns, improve a component's rigidity by increasing its resistance to bending and twisting. These factors work together to create a structure that meets its design requirements. Balancing rigidity and flexibility. One of the biggest challenges in structural engineering is achieving the right balance. A rigid structure is great for resisting deformation, but it needs some flexibility to handle dynamic forces like earthquakes or heavy traffic loads. Too rigid, and it may crack under stress. Too flexible, and it may fail to maintain its shape. This balance is carefully calculated using advanced analysis techniques and computer simulations. Engineers also test materials and prototypes to ensure they meet the necessary standards. Conclusion. Structural rigidity is all around us, shaping everything from skyscrapers to bridges and even your own home. It's a fascinating blend of physics, material science, and creativity. Thank you for joining us on this journey to understand rigidity. If you found this topic interesting, don't forget to like, subscribe, and share. Together, let's continue exploring the incredible world of engineering.